Hi and welcome to the next video focused on critiquing papers. So far, the content in this video content has focused on, by and large, the idea of a theoretical framework. So far, I've introduced introductions, what introductions are and how they're constructed, and in particular, the use of literature and argumentation to present a research question. That argument and literature is part of the introduction's theoretical framework, sometimes called a conceptual framework. Now, that theoretical framework is not just part of the introduction, and indeed your critique of the theoretical framework needs to extend beyond the introduction into the remainder of the paper. That is because the theoretical framework that exists within the introduction is only there to support the structure of the remaining paper. That is, the theoretical framework should be present throughout the entire paper. In this respect, the methods that are outlined should only describe the methods that are consistent with addressing the question associated with that theoretical framework. The results that are presented should only be the results relevant to the methods that were presented and relevant to the questions that were asked. Well, if that's the case, if so far we've focused on introductions and methods, the next thing for us to consider are the results sections. The results sections in which we present the outcomes of our analyses and we present those results. We outline not only what the outcomes are, but we give readers an illustration of them in a graph or a table. But of course, results sections are not just figures and tables. The important component that draws and holds them together is supporting text. But before we get to that idea, let's just remember that a paper itself is part of a series of nested writing funnels. You've seen the writing funnel so far when we've talked about introductions. The idea of starting with a broad statement and narrowing to the research hypothesis or research questions. The same is true when we get to the method section, where we start with a broad statement of where the study was conducted, what the population is, all the way down to the software that we used for analyses. Well, the same is true for the results section. Results start with broad statements around what broad outcomes were arrived at from the analyses, and then narrow down to the specifics associated with each individual statistical test that you conduct. So that is, there's a very logical structure associated not just with the paper itself, but with the structure of each section. And indeed, each section, introduction, methods or results, might have a series of writing funnels within them. Always, academic writing needs to be presented in this clear, structured fashion. So what goes into the results? Well, the results need to be presented in a logical sequence. In the methods section, I described how the methods are presented in a clear chronological fashion, in the order in which the work was completed. The results section should follow that structure as well. So that means that our results are often presented in the order in which we obtain them. Often that makes the most sense because later results are the consequence of earlier ones, just as later methods are the product of earlier ones. In the method section, for example, you collect data, then you analyse it. Here, in the results section, we might think about the data we collected and describing them in a descriptive fashion, means and standard deviations, and then going down to the inferential statistics where we test hypotheses. In addition to the text that makes up a results section, the text that guides the reader, There are non-textual elements, figures and tables. Now for more detail on those figures and tables, see the figures and tables lesson that was presented earlier in the course. But of course that clear text needs to be present. Clear text that lets the reader link those tables and figures together and understand their context. And those results are written in past tense. Now a lot of students struggle with this idea. Now it is a fairly straightforward principle. Perhaps it's best understood from the perspective of a tour guide. Imagine you are in a new place, a place that you've wanted to go to for a long time. There are sites, perhaps there are locations that you want to see, whatever those locations might be, and you have those in mind. Maybe you also accept that there are areas that perhaps a local would know best and local information that they could share with you as you walk around with them. And of course, that's the role of a tour guide. That's what your results section or a results section needs to do. Here, the tour guide is verbalizing important attributes, pointing out, look over there, there's this thing over there, and look over there, there's something else. But not only is the person pointing out these important features, but is then describing their relevance. That's what a results section should be. It should be a good tour guide. The text should guide the reader like a walk through important features, landscape elements, landmarks to see. And then the text, by referring to a figure or a table, is like the author pointing, like a tour guide, at a particular feature. And the feature that is looked at is, of course, the table or figure. Remember the tour guide analogy when you're writing or assessing a results section. So how do results sections normally structure? Well, typically, consistent with the writing funnel approach, results sections begin with a broad data overview. How many observations did you end up with? Samples, for example. You might have written about how many samples you had planned to take, but how many did you end up with actually after measuring all those sites or species or individuals in the field? Things change once you're out there and you're really collecting data. Sometimes people who collect data for you do a pretty ratty job, and you're left with having to discard their recorded data, and it's something you have to be really clear about. You can see perhaps an example here about a pretend example in which whether pigs can fly is tested, in which we collected a total of 60 pig flight simulations. Those pigs were for 4 different subspecies. 3 of the pigs didn't complete the flight simulation, so were excluded from statistical analysis. Now we might want to add a bit more detail in here about whether all of those pigs were from the same subspecies, but you get the idea, a broad outline of what data you have and how many of them there are. And then we get into the description of the data itself, or the results associated with testing those data. We need to be direct. We need to ideally write in first person. Now I emphasise that issue in the methods content as well, but writing in first person makes your writing much more direct. It's much more a statement from me to you if I write about what I did or what I found. Now that's not me being precious about I found this, but rather it is I found this. It's a clear statement and it reads much more easily for a reader. Bear in mind that a typical day might involve reading several papers and reading them in very little time, and having direct written material is a great help. Alright, note too in this example text that the results are presented in past tense. This is what we found in the past. These are describing our results in the past. So what we found that pigs who flew more than 10 metres were most likely to have a diet rich in da-da-da-da. Now, you can see underneath here that when we present our results, we need to present the evidence for those results. Remember, we're not proving, we're providing evidence. So key things that are included in here: our test statistic, our T calculated, the associated degrees of freedom, far, far too few, and then the associated p-value, the probability of H0 being true, the p-value, and then if there's an associated figure, that's presented as well. So here is our tour guide saying, these are the main results we have, and look over there, you can see them for yourself. Now, bear in mind that even if we do not have a figure or a table, we can still present results. If we have only one test result, we can of course present our results in text. So, whether there's a table present or not, we present our results. But when we present it, we sort of modify it just a tiny bit depending on what supporting material there might be. Let's say if there is no table, we might use our descriptive statistics: total weight of pigs, N of 60. How many were there? Great. Averaged to 26.3 kilograms. Standard deviation. Standard deviation, why? Because this is a description of data. Description, not inference. If we were making an inference, we might say the average weight of pigs varied significantly. The moment we use that word, remember, significantly or significance, we need to highlight what the level of significance was that we tested, always. Varied between groups, and because we have a table of figure, we don't need to include all the extra details. We can just point to that table of figure. There's no need to repeat it. So when we have a good results section, what are the things that we're aiming to do? Well, the first thing we're aiming to do is to provide an overview of all of the data, all of the results that we have. Then we use subheadings to guide the reader. Remember, the structure that we use in the methods is the structure that we should use in the results. So if there are different components, different tests that we conducted, try to separate them by subheadings. Not into lots and lots of subheadings that only have one or two lines of text, but logical subheadings that group like things together in a chronological order. Make sure that results are stated clearly and concisely, and they are all consistent with the existing theoretical framework put forward by the authors or by yourself in the introduction. Anything that doesn't or is not consistent with that framework has no place being there. Make sure that the results are supported by statistical results, and if they are present, the text refers to the figures in which those results are presented. That would be an appropriate use of tables and figures. If there are tables and figures, remember those key points associated with the figures and tables lesson, especially around the idea of captions associated with both, and that captions for tables go above, captions for figures go below. And always think about the use of an active voice. Those key points associated with a table. Remember, captions above and each column with a title and units. There must always be units there, otherwise we have no idea what we're referring to. For a figure, the caption is below the figure and the axes are clearly labelled, both with their units and a broader title. And if we have data that we're presenting that need error bars, the error bars need to be the appropriate type of error bars. And to answer that question, which one is appropriate, we need to ask ourselves, are we describing our data? If that is the case, standard deviation. Are we referring to our mean and our uncertainty associated with it? Standard error. If we are making population inference and we're trying to describe significant differences between things, it's a confidence interval. regardless, if we use a confidence interval down in our figure, we should indicate what level of confidence is used. Things to avoid. In a results section should not be interpreting the results, shouldn't be actually making comparisons and offering explanations for things. The exception to that is when the results and the discussion sections are combined. I always find that confusing, but some of the papers that you'll be reviewing this year have combined results discussion sections. Be aware of those. It does make following the theoretical framework a little more difficult, but it should still be obvious and present. Don't describe any methods in the results. If you get stuck into that practice, then it's clear that the methods section are insufficient in terms of describing what you did. All results need to be presented, so don't cherry pick elements out, but one of the things that you should never include are raw data, just endless table of raw data. No one is interested in reading it. While many journals require that you submit the data to online portals, you never include it in the paper yourself. Quite a few undergraduate pieces of work that I've marked in the past have included tables of raw data. It is such a no-no that we used to apply a mark of -10% to any use of raw data. You'll find that other academics around the campus take a similarly dim view of it. And of course, every figure and table that you make doesn't necessarily make it into your paper. Get used to the idea that papers and pieces of work involve much, much more work than you ever see in the final piece. You probably already have a sense of that for your own assessment. That is part of the process. The process involves testing ideas and communication approaches, and we need to narrow down the material we present to only the most relevant. So think about, if there are multiple tests that you conduct, try summarise all of those results for different tests into a single table. If you have a bunch of figures that are saying similar kind of related things, think about whether you can condense all of that information down into a single figure or a couple. And if you only have a couple of results, ask yourself why you're putting together a figure in the first place. Is it something that you could just write in text? Well, how does all of this refer back to the assessment? Well, remember the rubric associated with the conceptual critique for the assignment. The results section is part of that conceptual critique, in which you need to ask whether the results section itself succinctly summarises the results that are relevant to the introduction. That is, results that are relevant and appropriate for the theoretical framework that the authors have put forward.